What if I told you the most powerful force in our economy wasn't money, or machines, or manpower, but something you literally can't even hold? Welcome to The Explainer. Today, we're diving into the economics of the one thing that really drives progress: ideas.
All right, so here's where we're headed. We're going to start with a mystery that stumped economists for decades. Then we'll get into this really big debate. Are all the best ideas already behind us? We'll figure out what makes an idea so special from an economic point of view, and then, and this is the cool part, we'll see how they actually help us grow from the inside out.
Okay, so for the longest time, economists had this huge gaping hole in how they understood economic growth. I mean, their models could explain what happens when you add more workers or more machines, but there was this massive piece of the growth puzzle that was just gone.
Yeah, they could measure the impact of, more labor and more capital, but they knew that wasn't the full picture. Not even close. There was this huge, unexplained chunk of growth. So the question was, what on earth was this missing piece? Well, in the old-school economic models, the single biggest driver of our prosperity, technology, was treated like magic. They literally just called it Factor A and assumed it kind of fell out of the sky. It was a complete black box. Nobody knew what was inside it or where it came from.
And that's when an economist named Paul Romer came along. He decided it was time to finally crack open that black box. And what he found inside changed everything. That missing ingredient? It was ideas.
See, Romer's big insight is that we are constantly underestimating what's possible in the future. And that's because we tend to think in terms of addition, when really we should be thinking in terms of multiplication. As he famously put it, the possibilities don't add up, they multiply.
Just think about it for a second. Thousands of years ago, right? We took two basic elements, copper and tin, and we combined them to create bronze. That one idea, that one combination was so powerful, it literally named an entire era of human history. Now, fast forward to today, we've got over 100 elements on the periodic table to play with. The number of possible combinations isn't just big, it's practically infinite.
But not everyone is so optimistic. And this brings us right to the heart of a huge debate about where innovation and growth are actually heading.
So you've got this big clash of ideas. On one side, you've got Romer and his vision of an infinite ocean of possibilities. But on the other side, you have another economist, Robert Gordon, who makes this really provocative argument. He says, look, the low-hanging fruit has already been picked. The truly game-changing inventions, they're mostly in our rearview mirror.
Gordon points to these three massive waves of innovation that completely remade society. And his argument is that, the computer and the internet were a big deal. Their impact on overall productivity just doesn't hold a candle to something like the discovery of electricity or the invention of the internal combustion engine. I mean, those things changed everything: how we live, how we work, even how we eat.
And this isn't just a hunch for him. He's got the data to back it up. He shows this major slowdown in U.S. productivity growth right after 1972. So from his point of view, it looks like that big engine of progress is starting to run out of steam.
Of course, it's probably worth remembering that being pessimistic about technology is nothing new. History is just jam-packed with quotes from really smart people who were completely 100% sure that new inventions were either flat-out impossible or totally useless.
So who's right, the optimist or the pessimist? To even begin to answer that, we have to get back to basics and ask a really fundamental question. What even is an idea in economic terms? What makes it so different from a physical object, like a pencil or a smartphone?
Okay, so most things in the economy are what economists call rival goods. It's simple. If I'm using this pencil, you can't use the exact same pencil at the exact same time. If I buy a latte, that latte is gone. You can't also have it. The use is competitive.
But ideas are non-rival, and this is the key. Think about a recipe for chocolate chip cookies. You can use it, I can use it, a million other bakers can use it, all at the same time. And the recipe itself is never used up. An idea doesn't get depleted when you use it. It's infinitely shareable.
All right, so that brings us to the next big question. Once an idea is out there, can you actually stop other people from using it? That's what we call excludability. A movie theater sells you a ticket to exclude anyone who hasn't paid. But how do you slap a ticket on something like the Pythagorean theorem?
And this distinction, rival versus non-rival, and whether you can exclude people or not, this is absolutely critical, because it creates two totally different but incredibly powerful paths for economic growth.
So let's look at path number one. When an idea is non-excludable,
Think about a fundamental scientific breakthrough like E equals mc squared. You just can't keep it in a bottle. It spills over and ends up benefiting everybody.
This creates what economists get excited about: positive externalities. Basically, the benefit to all of society is way, way bigger than the private benefit to whoever came up with the idea first. These spillovers boost productivity all over the place. It's like a rising tide that lifts every single boat, and that's what really pushes the whole economy forward. But what about that second path? What happens when an idea is excludable? When you can protect it with something like a patent or a copyright, or just by keeping it a trade secret? Well, that sets up a completely different economic game.
Think about developing a new drug or a new piece of software. The upfront research and development costs are huge. That's a massive fixed cost. But once you have the blueprint, the cost of making one more pill or one more digital copy is practically zero. And this economic setup, high fixed costs, super low marginal costs, that's exactly why industries like tech and pharma often end up with a few giant dominant companies. The system just naturally rewards scale.
Okay, so the theory seems pretty solid. Investing in ideas, whether they're public goods or protected products, is the real engine of modern growth. But is that actually what we see happening out there in the real world? Let's look at the data.
And this chart right here tells a really powerful story. If ideas are the fuel, then researchers are the people building the engine. And as you can see, the slice of the workforce that's dedicated to R&D has been climbing and climbing in all the major economies. This isn't an accident, it's a conscious global effort to produce more ideas.
And it's not just about the number of researchers either. Just look across the board. The money that private companies are pouring into R&D, the number of patents being filed, the insane growth in software investment, all the indicators are pointing in the exact same direction. We're no longer waiting for Factor A to just happen. We are actively trying to build it ourselves.
So here's the bottom line. Economic growth isn't some mystery that just falls from the sky anymore. We now understand that it's an engine that we build, that we fuel, that we maintain ourselves. And the fuel is ideas. Which leaves all of us with a pretty important question for the future. Are we investing enough to keep that engine running for the next generation?